My name is Oleg Zhurakousky. I'm currently a tech lead for Spring Cloud Stream project. And I'll talk to you about, today we'll be talking about Spring Cloud Stream, kind of talk about some of the developer recipes, some of the patterns within Spring Cloud Stream. We'll talk about what's new in Spring Cloud Stream 2.0, which was just released about a month ago. And we're definitely going to be talking about what's next. And with that, I have to show you this slide. Don't try to read it. This is just something that I have to do because this particular presentation will include some of the spikes that we're currently working on, something that may or may not make into the framework or in what state. But the reason why we like to do that is obviously a product is not a product unless it's useful. And we would like to solicit the feedback as quickly as possible before we commit to something. I would truly appreciate if, when I get to that point of presentation, in a presentation, that you think through it, try to understand why are we doing this, or why are we trying to do this, and ask questions. Now, with regards to questions, I don't personally like to wait till the very end, so I would prefer, like, if somebody has, within the context of a question, raise your arm. Unfortunately, I may not be able to see you, so the guys in the front row, please ask questions, because that's about the only people I see. Let's begin. Here's our quick agenda. We're going to talk about, the scope. This is the scope, actually. So we're going to talk about the cloud, the event-driven architectures. We're going to kind of put everything together. And like I said, we're going to talk about what's new and what's next. So a quick show of hands. How many of you are familiar or users of Spring Cloud Stream currently? Great, not too many. I hope to change that. How many? Well, obviously the rest have not used it, which is good because I will try to tailor it to both the ones that are using it as well as the ones who are new, hopefully to turn you into this great product. I guess with the Spring Cloud Stream, so our industry is very sort of rich in coming up with buzzwords. We used to have SOA, service-oriented architecture, then that kind of got old, so we come up with the cloud. Now that's getting old, we're getting into serverless. I wonder what's going to be next. But since we're still using the word cloud, again, means too many things to many different people, so I like to always kind of scope it out, at least for the sake of this presentation. So to me, cloud is the ecosystem that integrates platforms and middleware into one cohesive hybrid runtime. So we constantly deal with messaging, file system, databases, and right now with the variety of different remote services like Amazon Web Services and so on and so forth. So again, that's your cloud, right? So it outsources infrastructure concerns to the cloud provider via cloud connectors and services and provides the mechanism for application services to interact with those services. And naturally, this interaction is event-driven. And by the way, how many of you have been to Dave Sires' presentation earlier today? Good. More than Spring Cloud Stream users. So, events. What are the events? What is an event, right? So event is a representation of a state change. It's always in the past tense, right? So when we're looking at the event, right, it's already happened. It's not something that is happening right now. It's already happened. It's in the history. I actually talked to one of my colleagues, John Schneider, who is the project lead for Micrometer, and he kind of said that sometimes even the method naming can be wrong, because think about local time now. What does it return you? At the time you're looking at the result, it's no longer now. It's 2 seconds ago, right? So events are delivered in the form of protocol-specific records using some messaging middleware. Rabbit, Kafka, the good old JMS, and or sockets, right? So main delivery mechanism. And a typical event, what sort of separates event from just a data point is the fact that event contains not only the payload, but it also contains the metadata. And for those of you who are familiar with Spring and Spring integration, which we'll talk about in a second. We look at the event as kind of standardized eventing around the concept of a message. And as you can see, the message is a very simple, basically, structure. I mean, you can call it a tuple, I call it a message, but it's really an object and a map. It cannot get any simpler than that. So the object corresponds to a payload, and a map simply corresponds to a metadata that you want to communicate with that event. And again, it's very easy to correlate to our everyday human interactions. I mean, look at the letters, look at the emails. I mean, we always pass a payload, and there is some meta information coming with it in the form of a subject, address, and so on and so forth. And then there's streaming. So streaming is kind of a subset of event processing, because streaming is really more about the programming paradigm than just a streaming, like just a, it's not really different. It's not the difference between eventing or streaming. It's really more about that streaming allows you to address your event processing in a slightly different way, where you define processing graphs, each event injected into the graph operators, right? So you have a sequence of operators, and those operators pass these events after processing between one another. That exposes you to a lot of very interesting use cases, because now you can define what you want to do, but then you can, within the graph itself or externally, can alter how it's going to be done. For example, do you want the graph to process concurrently, or do you want it to be sequentially? Do you want to have some window operation on the graph, right? Do you want to look at the stream of messages as some kind of a batching, group of events? So, and you got a little example of how that may look like, and I'm sure you already seen similar things with either Project Reactor, Scala, Spring Integration, DSL. I mean, there's many different ways to kind of slice this cat. So, finally, we get to the point of where does Spring Cloud Stream comes in. Before we even get to that point, another quick show of hands. How many of you are familiar with, well, there's two questions here. How many of you are familiar with the book cover that is, I guess, on the right to you? All right, good. Oh, impressed. So this is like when a long time ago when we worked on a Spring integration, like in the early stages of Spring integration project, and I hope not to offend anybody, but this was pretty much our tech Bible or a map or spec for developing the framework. So we literally tried to follow it to the T. And so, in other words, a lot of times when I was doing presentation on Spring integration a while back, I was always saying that Spring integration is basically a reference implementation of this book. So, and Spring integration, so at the heart of Spring integration, at the heart of enterprise integration patterns is the very simple yet concise pattern called pipes and filters, which basically says that producers, consumers are absolutely unaware of one another because there is a pipe in between them, right? So they're not passing events, messages to one another. They're only passing events, messages. I'm going to stop calling events, just messages. They're only passing messages to and receiving them from the pipes. That architecture allows in itself a very interesting, exposes a very interesting programming paradigm, because while you work on implementing a particular processor, filter, transformer, whatever, you don't have to worry about how that piece, the result of your transformation will be consumed or how you even get to the next component. Will it be event-driven? Will it be concurrent? Will it be pollable? You don't really know, because you actually, those details were always was responsibility of the actual pipe, we call them channels, and the dispatchers or polling consumers that are responsible to operate on those channels. So, and Spring integration essentially served as a map, in other words, to Spring Cloud Stream. So if you look at this diagram, right now it kind of represents Spring integration, but if I remove the header or change the header to Spring Cloud Stream, from the diagram perspective, nothing would change, and we'll see that later. In other words, the pattern is still the same, except that what we're introducing, what's different between, well, we kind of on the next slide already, what's different between the Spring integration and the Spring Cloud Stream is that we've taken essentially Spring integration ideas and enterprise integration patterns ideas into distributed world, where I'm going to go back for a second, where these boxes are now individual components, individual Spring Boot applications, and the channels that connect them together with another product. Well, we have another product called Spring Cloud Data Flow, which allows you to essentially build these pipes. Allow you to provide the distributed, utilize distributed messaging mechanism like Kafka, Rabbit, to exchange between these producers and consumers. So again, it created for us, it created a concise view into how we want to look at the complex event processing, but it also, created, well, not created, it also has its own set of limitations because Spring integration is a framework, it's a developer framework, so it didn't define any sort of a programming model in terms of kind of a true distribution. So whatever you assemble outside of, unless you're dealing with adapters inbound or outbound, kind of set or resided within the same JVM, right? So and essentially you're getting into the concept of shared resources and so on and so forth, right? So what we wanted to do is kind of break it apart, not necessarily Spring integration. We still use Spring integration within Spring Cloud Stream, but break the concept apart and say, listen, we're going to utilize the best what's in Spring integration to implement a higher level but similar pipes and filter type product. So, and that's where Spring Cloud Stream comes in. So Spring Cloud Stream is a framework to build highly scalable, event-driven, or streaming microservices. So it provides boot-driven integration with message brokers and destination binders. We're going to talk about the binders in a second. So it leverages native features of brokers while also providing a workaround for not supported features. For example, how many of you use Kafka? Good. So you're familiar with the concept of consumer groups and partitions. But those concepts do not exist within Rabbit. But there is certain benefit in using those concepts, right? Where you can do sort of selective parallelization, where something within the same consumer group will be sequential, but between consumer groups is going to be parallel. So does this mean that you cannot, if you're stuck with the Rabbit, which I personally prefer more, as your messaging middleware, does this mean you cannot utilize that feature? Well, purely within Rabbit, you can't. But because Rabbit provides an internal mechanism for routing, right? You send to Exchange, you receive from the queue, and then you can define a variety of different routing rules. It was actually very easy to implement, sort of artificially, the concept of consumer groups and partitions, right? So, in other words, now you can utilize the same concepts using either one of those messaging middlewares, and in fact, these are the only two we currently support, right? But, well, using Spring Cloud Stream. If you were to go straight directly at Rabbit, you would have to pretty much do everything that we did there to make that happen. So, and that's one of the sort of a great benefit of a Spring Cloud Stream. So it also honors application configurations by the underlying frameworks. For example, again, for those of you who are already using Spring integration today, you're probably familiar with things like service activator, transformer filter, and so on and so forth. You may even have XML-based configuration. Or you may already switch to annotation-based configuration, right? You don't have to, if you want to migrate this application or break it apart, but reuse as much of what's already been developed and wired as you have, you don't have to really change much. You have a handler which is annotated with that service activator. You can still use it. Spring Cloud Stream will honor it. Because again, internally it is backed by Spring integration. So if you're using Kafka, like Spring Kafka project, then you can say Kafka Stream, and or whatever the annotation, I forgot, Kafka's handler, or anyway. So you can use that. And if you're new to Spring Cloud Stream, you can use our internal, which we'll see in a second, annotation stream listener to annotate that particular message handler. So another feature of Spring Cloud Stream is that when you're writing your code, you kind of don't want to deal with a message unless you want to. You probably want to deal, let's look at it differently. When I ask you to write me some code, I don't necessarily want to disclose as much and burden you with the internals of Spring Cloud Stream, messaging, eventing, and everything else. I have an employee or a person or account, and that's what I want to pass you. Well, that's what I want to ask you to implement, right? Something that will receive an account and will do some manipulation on that account, right? So, but that data will arrive, and it will arrive both in the form of a wire format and eventually going to be encapsulated into the message. So you can take it as a message, parse everything out, recreate that account object yourself, or you can use our transparent content type negotiation and argument resolution, which we'll see in a second when I switch to the demo part, which will do it for you. It provides the ability, as we already discussed, to connect microservices to the external systems via the concept of a binders. So we have Kafka, RabbitMQ. That are currently production supported, I guess would be the right word. And then JMS, that's currently in works. And there's more binders that are being kind of considered. It also provides a flexible programming model, which is built on familiar Spring idioms, supports pub/sub semantics, consumer groups, as I already mentioned, stateful partition, and other messaging paradigms. And again, it is message-centric, so I cannot underscore the value of the concept of a message, simply because of its simplicity. And supports right now, especially with the Spring Cloud Function project, which we'll touch on in a few minutes as well. It supports imperative and declarative programming model. So let's look at kind of we'll switch to the IDE in a second, but just to give you a quick idea of what Spring Cloud Stream application looks like. It really is nothing more than a method, an operation, that is annotated with, like I said before, with a stream listener, or service activator, or transformer, any one of those annotations that the framework will know what to do, right? What's interesting is that, again, what you see from the code is that the body of either one of those methods has no knowledge or awareness of Spring Cloud Stream or anything remotely related to Spring Cloud Stream or Spring integration or anything else. And that's kind of sort of something to bookmark for something we're going to be talking about in about 20 minutes. So in the first example, we're using imperative programming model where we simply define a message handler. It's going to be invoked every time the message arrives, and the data from the message is going to be converted to match the string. So again, there is certain convention over configuration, things that you sort of have to be aware, and those are derived again from the patterns we use in Spring integration. So for example, if you pass a POJO, we assume you want the payload of the message. You can also pass the POJO and a map as an argument when you declare your handler method. We will know that you want us to extract the payload and headers. If you just pass the map, that's kind of exception to the rule. We're not gonna, it's technically a POJO, but because it's a map, we're actually gonna give you only headers. And if you say message, we'll give you the entire message. If you say, and also a very interesting thing about this content type negotiation that I mentioned earlier, which we'll talk more in details in a few minutes, is that think about the fact that we're living in a distributed world. So the message payload, when it arrives from the broker, what is the payload type? What do you think? What can it be? Can it be foo? Probably not. Because we're dealing with a wire format, so it could come from technically a non-Java system if you think about it, right? So it has to come in some form that is portable across a variety of different environments, especially when we're dealing with brokers that aren't not like JMS, which is specific to Java. We're dealing with something that is completely portable polyglot, right? So the payload is always going to be a byte array, right? So there's definitely, every time you leave the boundaries of your Spring Cloud Stream microservice, there's going to be a serialization and deserialization from and to byte array. All right? So, and if you say message question mark, we'll give you exactly the raw payload. But if you say message employee, we're essentially saying you want to get a message. You still want to get the entire message, but you want the payload of the message to be converted to a particular POJO type. And we'll do that for you. And I can explain later on how we do that. But the point is that that's a convenience that you as a developer, something that you don't have to do. Going back to the good old Spring where let us worry about boilerplate, you worry about functional. And that message kind of doesn't change. And then in the second example, obviously, if you are into reactive style programming, you can just do Flux. Today, this programming model would be supported with Spring Cloud Function being on the class path, and we'll look at it in a second, but you can do it. And we're actually looking at enhancing it greatly, and that's something we're going to look at later on today. So, and finally, this is the kind of the whole view into what Spring Cloud Stream is. So, the destination binder or binders, it doesn't have to be the same. It could be two different binders. You don't necessarily have to bind to the same messaging system. So you can receive messages from Kafka and output them to Rabbit or vice versa, or implement your own binder and receive and send messages there. So the binders essentially provide a binding between the source and target destination of your message brokers to the internal input and output channels that are provided by Spring integration. So if I go back to the programming model, you see processor input, processor output. Those are the names of the channels, input and output, right? So the binding, and I call it bridge binding because you're bridging the broker destinations with the Spring integration channels. And the benefit of that for those of you who are familiar with Spring integration, or for those of you who are looking for consistency and maybe simplicity around testing, you can just simply operate at the level of channels and not worry about how we bind to the message brokers. So again, the bindings are between the, currently we call them channel binders. So they're, or like I said, I internally call it bridge binders. They bind the destinations, the broker destinations to the channels, and then they're also responsible to provide invocation model for your methods and operations, where finally when the message arrived, I have to convert it. Because those components are the only ones who are actually aware of your payload, of your argument type. So we actually look at the argument type, using a bit of a reflection there, and say, okay, well, we received the message, the user is looking for an account to be received, so we're going to extract the payload and convert it to account. And there's a different mechanism how we do that. So, and then we invoke your code, and once the code is being, in a case of a input and output, once you return whatever it is you return, you can return a message, and we'll honor that as a message. But if you return an object, we're going to say, okay, we're going to create a new message, we're going to use your object as a payload, and copy certain headers from the input message, and add additional headers to signify that this is an output message, and so on, and continue with the process. So that's pretty much it. This is pretty much what Spring Cloud Stream is in a nutshell. Again, as everything else right now in Spring, it's a Spring boot app, flexible configuration. So as you can see, I put the acronym XML in there. I'm still a fan. I don't know why. I guess I've been with Spring for longer than to actually forget about this, but I never personally had any issues with that, but the point is that it's your choice. You can use one or the other, or you can use hybrid. So binders, we have, as I already said, we support Kafka and Rabbit, and we also support within the Kafka, because Kafka, again, provides some of the native features like case stream. So we actually have a case stream binder to simplify interaction with Kafka streams. And it's also very important that when as you've probably seen, Spring portfolio has exploded in the last 5 years. So we have a lot of different projects to handle, a lot of sort of non-functional use cases. And what we try to do is to analyze not just our own projects, the ones we're leading, but also kind of the ecosystem around us, and say, well, listen, there's something I can reuse from another project. So we provide a seamless integration with a variety of different projects. I just named a few there, and we're going to look at one of them, like metrics, but Sleuth, Config, Circuit Breaker, we provide seamless integration with all of them. So summary, durable publish-subscribe messaging, consumer groups, declarative data partitioning, content negotiation, flexible programming model, and we also have a Avro and schema evolution story there as well. Finally, we get to write some code. Before I go there, any questions? All right. Okay, so can you guys see the code, or should I make the fonts bigger? Good? A bit bigger. The whole point is not to show you a lot of code, because there's not supposed to be a lot of code. Right? If there's a lot of code, then we're doing something wrong. So I'm going to temporarily comment this and comment this. And at this point of time, it's just a Spring Boot application, right? So enable binding, that's one of the native Spring Cloud Stream annotations. And what it'll do, it's simply, if we look at what sync is, it basically defines a channel called input, and we'll create it for you. And we'll bind that input channel to the broker destination. So what I was saying earlier, you send message to the broker, and I'll show it to you in a second. We're going to be using Rabbit. I'm going to send message to Rabbit, and it's going to get somehow right into your application. So the framework takes it as a signal, will create those channels, and will bind them to a broker. And then stream listener notation, you're saying that this method should be treated differently. We're going to post-process it and say we're going to create essentially an invoker, say whenever the message is, message handler, whenever the message arrives to this channel, we're going to invoke this method with this payload, with a payload of this type. And as I said before, the payload is going to be converted. So that's pretty much it. You can actually go and start.spring.io, and let me try to do it. How many of you are familiar with start.spring.io? Okay, Josh has a really good way of presenting it. If you feel neglected, abused, sad, go to spring.start.io. So, okay, he does it better. So, and at this point of time, you would create, the group name, the artifact name, and the important part here, you say stream. You can put Cloud Stream, and you say Rabbit or Kafka, whatever, and that's it. You're ready to generate the project, import it. This is it. And at this point of time, we're here. All you need to do is say enable binding annotation, stream listener, and if you have Rabbit running, that is all you need, because you don't need any additional configuration to tell it where Rabbit is. Because again, convention over configuration. We are opinionate with boot. We come not just with good code, but also with an opinion, and we know what the default port is. We know what the default address is. So we'll attempt to connect there. If you want to override, you can always do that. But for now, that is all. There's no configuration to look at. So I'm going to start this application. Sorry, my Eclipse is a little... I haven't rebooted my machine in like a month, I think, so probably should have done it. But so we are running. So I'm going to go to Rabbit. And it created the input hello. Now, one thing I have to mention, typically if you do it yourself right off the bat, you will see input.some gibberish, because it's going to be, so the format is queue name or destination name dot group name. So if you don't provide a group, we'll create an anonymous group, and it's going to be anonymous in some gibberish, right? But right now I did provide a group just because it's simpler and easier to follow. This is it. So now I can go here, go into this input hello. I named my group, I named my group for this demo as my group. So it's input my group. I'm going to go here. I'm going to send some message. And here we go. Hello, Barcelona, right? So again, I send it to the Rabbit queue. It arrived to me as a string, right? So there is some conversion that happened, but obviously this is a simple conversion. So what if I created this poser called person, right? What if I want to send a person? So let's try to change this payload to, and this is I'm kind of getting into the content type negotiation. So I'm going to say, I'm sending you a person. So now I'm going to basically express how I'm going to express define a person. So I'm going to use JSON. And we got a person, so I implemented a toString method. So again, the conversion has happened. If I wanted to pass you the entire message, for example, if I go give you a, well, I don't want to call it payload because it would confuse a lot of people. Oh. I have to start and stop because here we got the entire message, and as you can see, the byte, the payload was not converted because we didn't specify which payload do we want. Now, sometimes I wish we had the same format we used to have, like 90 minutes, because I'm running slightly behind. So again, any questions so far? Okay, so I think I've covered kind of the gist of it. Obviously, there's a lot more to that. I was trying to show you the error handling, but I really want to get to the point of the cool stuff, something that we're working on next. So, and again, if you guys are interested in things that I'm going to skip right now, approach me after this talk, and I'll be more than glad to show it and discuss it with you. So, so what's new in Spring Cloud Stream 2.0? So we used to have this kind of an issue, well, content type negotiation was improved dramatically. One of the issues that we had before, especially, we were doing this conversion based strictly on a content type header within the message. The problem with that we encountered very quickly was that we were trying to address the problem that was really not the issue that we were supposed to be addressing, because we were trying to, for only textual payloads, to convert the payload of the message to string, but if your handler defines a person as an argument, then we would have to convert that string to a person, for example, right? So we were doing this double conversion that had absolutely no reason. And also we're doing it only for certain cases and not for other cases. So when this type of happens, that's usually kind of a red flag when you're doing something for one case but not for the other. It wasn't really consistent. So we kind of revisit this whole thing and also came up with a default content type, which means that this is how our person was converted without you doing anything, because default content type right now is going to be application JSON. You can communicate it through message header. You can communicate it by saying that this message channel should be bound to a content type so-and-so. But if you don't do anything, it's going to be application JSON. So again, convention over configuration, because we've analyzed our community, and basically we're told that most of us are passing data around as a JSON. But then we support Java serialization, we support Cryo serialization, we support other type of things, and most importantly, we allow you to add, we do it through the concept of a message converters, which come from Spring messaging, and you can implement your own message converter and register it with add stream message converter annotation within your application context. So that's kind of quickly on the content type. We have a polling consumer, which is a very interesting concept that always existed in Spring integration, but not in Spring Cloud Stream, which means that right now, everything is event-driven. The message arrived, the message is going to be sent to the next to the consumer. But what if you're dealing with a situation where you don't want to be kind of spammed by thousands of messages as they arrive? You want to, because remember, those destinations from brokers like Rabbit and Kafka, they're queuable. In other words, they can accumulate stuff, right? So we kind of give you this sort of a rudimentary mechanism to throttle. In other words, you can define your own, you can define binding to the polling consumer and simply decide, I want to poll it every second, or I want to poll it every 2 seconds, or whatever. So again, there is, I'm going to kind of skip to the very last point, because we completely revamped our user guide. So the documentation was completely updated from top to bottom for the 2.0 release, and we've revisited pretty much every sentence, every word, and it's really up to date. You can go there, and there are samples, and you can play with it and see how it works. So new actuator endpoints for binding control. Again, I'm going to show it to you really quickly. My application is still running. So if you want to see what your binding is, and when everything was bound, I mean, obviously you didn't do anything to bind to RabbitMQ, right? But we did it for you, but you want to be able to see what it is. And now you can hit the actuator endpoint, and in fact, this is what this property was for, to enable actuator endpoint for binding. So that's a Spring Boot. And yeah, so now you can see all the bindings, all the properties, things you can set, things, and also visualize how things are set. You can also control and say, listen, you want to be able to stop this consumer or start this consumer, or in the case of Kafka, you can also pause or resume the consumer. So we provide ability to not only through REST API to visualize those endpoints or bindings, but also to control them. For example, if I switch it to stopped and refresh it, right now it says running. Right now it says stopped. Start it. Start it. And you can see in the logs how it connects and disconnects from Rabbit for that purpose. So what else? Metrics. Yeah, metrics is running right now, so I already had it set up, and the only thing I needed to do is just import whatever meter registry I want to get into and work with. So if you look at, I just opened Visual VM, I'm going to look at my mbeans. I go to Spring Integration and message channels and input channels. I mean, I can't make it bigger, but the point there is you can see the rates of message processing, how many messages, a variety of different metrics information. And since everything is being converted to use micrometer, it's really up to you which meter registry implementation you want to use. Just drop any one of them in the class path, and that's exactly where the metric information is going to go to. So native support for Apache Kafka streaming. I'm not even going to go there. There is a link. Josh Long did a presentation. It's also available on our release blog right here. So you can go and see it, and that's as everything Josh touches is a beautiful presentation. Web support is now optional. We're also deprecating Java and CRI-based serialization. Again, primarily because we're living in a distributed world. We cannot assume that we cannot base our interaction on a type system, right? So we may be dealing with producers and consumers who are not even Java-based. So we need to be kind of careful with that. So, and as I mentioned, we revamped the user guide. So finally, where do we go from here? I have about 12 minutes. So bridge-based binding. If we look at the bridge-based binding, so it's a source to target to side channels, right? So we have the user, and it kind of makes you aware. If you look at the application the way it is right now, you may say, well, why do I need all that? Because the only functional code that I'm worried about writing is this code, right, inside of the body of the method. Why do I have to worry about all this stuff? Furthermore, why can't it be done later at the assembly time or at the deployment time? The another question would be, skip ahead. Yeah, so, and on that, so the other thing was it introduces kind of unnecessary misdirection, because the goal of the binder, if you think about it, if you try to explain the concept of a binder to somebody, the binder's job is to provide connectivity between its broker and your code, right? So there's many different ways to do that. And right now we're saying we're going to provide the connectivity between the broker and a channel, and then utilize Spring integration to distribute information from this channel through its dispatching mechanism into the actual your code. But can we bypass all that? And don't get me wrong, I'm not trying to say don't use Spring integration. Again, as one of the original engineers, that's one of my favorite frameworks to this day. But use it when you need to use it. Use it when it makes value. But what we're thinking about right now is saying, listen, can we have a different style of binders that, and I'm going to call them like a pure destination binders, which simply allow you to and create a more convenient and robust and extendable API that would allow users to create binders to not only the well-known messaging systems, but to a variety of different mechanisms. For example, Can you have a binder and tail a file? Why not? Right? Again, we haven't really experimented with this, but this is kind of something that we're at least discussing. Spring Cloud Stream infrastructure mixed with functional code. That's what I was trying to say before. So this, again, it's a debatable because those annotations, I mean, you can call bean infrastructure annotation or controller infrastructure annotation, but still, you want to be able to develop a functional code, and you want to be able to make sure that this functional code could be invoked not only within Spring Cloud Stream, but with a variety of different other things without you ever changing this code or without you ever repackaging. So complex message processing use cases. Right now, we just simply pass the message as soon as it arrives to the queue. But what if you want to do some windowing? What if you want to do some batch transaction type processing? What if you want to look at the message reception as sort of a group of messages and say, okay, well, I'm looking at it as a group of 5, and if the 5th message fails, on my retry, I want to be able to retry, but I don't want to retry the 5th message, I want to retry the whole group, because that's what constitutes this pseudo-transaction to me. And then again, I'm going to go back to Dave's, the whole serverless Java 8 functions. It's event-based, it's dynamic resource utilization, scale to 0. I mean, what if those paradigms are important to you? What if this is something you're working with? You want to really focus on the business logic, and that's really the goal. So, and then cross-platform, I'm going to skip to this slide because I couldn't quickly find a proper way to what Dave was showing earlier today. Cross-platform functionality where you say, okay, well, what if we have Spring Boot, then we have the serverless provider which provides you with functionality in the form of functions, consumers, suppliers, and then you have adapter to ensure that they can work with with your code. And essentially, what I'm sort of heading towards is a Spring Cloud function. It's kind of like what we're sort of, and this is where this forward, not so forward-looking statement comes in, where we're starting to look at with Spring Cloud functions and with its imminent, I guess it's safe to say, release. We are sort of saying, okay, well, what if Spring Cloud Function were to become a de facto programming model? And Spring Cloud Stream will fall into a binding framework, only to provide a variety of different binders, binding mechanism, binding APIs, so you can create your own binders, right, for a variety of different systems. So, so now, when you look at this code, imagine that everything stays the same, but you remove at stream listener, you move at send to, you simply utilize certain convention or configuration, but again, external configuration to say, I want to be able to use this and bind it to this destination and bind its output to that other destination, right? So now, the other problem, or not the problem, again, something to think about. I don't want to use the wrong words. I call it, again, for the lack of a better term, a source-sink conceptual mismatch. If you can see from this diagram, right, we have source pulling from SFTP, and we have sink that writes to JDBC. And then we have a processor in between. But what's interesting is that the source, processor, and sink are the apps themselves, which means you pull from remote system and immediately putting it into other remote system. Don't get me wrong, it has value, because this architecture allows you to drop processor or stop it temporarily for upgrade or something. Meanwhile, your source is still functioning. But what if that's not what you want to do? Why can't source, which basically doesn't do anything other than producing the source and sends it to the queue, why can't it send it directly to my handler? And the other thing, Java 8 functions, basically Java util functions, the 3 interfaces, the supplier, function, and the consumer. Now, if I ask you a question, is there a use case that you can think of that you cannot map to either one of those 3? Ever? I mean, yeah, they're very generic, and we could extend them, but everything in this world, either supplier or consumer or a function, right? So now, what if I look at the world, this is again with a Spring Cloud function coming, and say, listen, let's just look at everything and develop it as functions, or consumers, or suppliers. And binding frameworks like Spring Cloud Stream will provide a mechanism to actually bootstrap them within Spring Cloud Stream and bind it to a destination. Or other framework, you can say it's going to be my REST controller, and the REST framework will take care of mapping the HTTP request to the invocation of this function. But the function itself doesn't change. And it could reside in your repository, it could reside in some library, it could reside in some remote repository, and you can have, as Dave was suggesting, function catalog, which is provided by Spring Cloud Function, and So, and this is what I was saying before. So if you try to say, okay, well, this model is not really good for me because I really don't want to utilize, not necessarily don't want to, I may not need to introduce a remote queue just to pass the message from a source to a function, right? Why can't I have just a binder that will bind me directly to SFTP, and a binder that will bind me directly on the output side to JDBC? Furthermore, because of Java functions, in other words, everything, like you look at any method, you can always look at it as a function, a consumer, or supplier. But one of the benefits of Java 8 functions is that it provides the composition API. So for example, I can compose functions, suppliers, and consumers together. So imagine you have a library of functions, and you say, okay, well, I have 3 functions. I may want to bind them to a different destination for this application. But for the other application, I may want to compose them into a single function, and the result of that composition is what I'm going to bind. So you're still creating the chain. You can still address these concerns, the complexity as a separate concerns, but then at the deployment time, you kind of squashed it into one and say, just run it for me. Okay? So again, I have 3 minutes. So we're pretty much done. So quick demo. So what I'm doing here is this is like a Spring to function way of looking at the world. So in this particular case, you're looking at, let's just call it Spring Cloud Stream Application 3.0 or so, right? So the interesting thing you will notice right away, there's no enable binding, there's no at-stream listener. For all intents and purposes, it's a pure Spring boot app. Agreed? So I'm going to actually run it in debug mode and put a breakpoint, and because I wanted to sort of introduce, when I was talking about this windowing and stuff like that, where we're utilizing internally Project Reactor to implement this very interesting use case. So I have messages, I already pre-populated the queue on the Rabbit, and I have messages that are, the first message has 1 byte length, the second message has 2, 3, 4, and so on and so forth, right? So it's easier for me to track. So right now, it printed that I received the message with a payload of 1 byte, then 2, right? Then 3, and now I'm saying my fail count is set to 3, just and I'm going to crash, right? So look what happens now. Look what I'm getting back. Because I've defined my window internally through configuration as 5. So right now the window didn't complete, so as if my transaction didn't complete. So I'm reprocessing during a retry this particular transaction. And if I look at the Rabbit, the mechanism, again, there's various different mechanisms. Right now, we handle this retry locally. But if you look at the Rabbit, right now, I had 19 messages in the queue. You can see that 5, because I set my window size to 5, 5 have been retrieved, but they're not removed yet. They're not committed in the removal. And what's interesting is that my message listener container will not be prefetching any more messages until this batch commits. Right? So these are the things we are currently looking at. And again, to summarize it, is that Spring Cloud Function is de facto programming model, or we would like for it to become a de facto programming model. Your application should be nothing more than Spring Cloud, nothing more than a plain Spring Boot applications where you define the functions. And in fact, I don't have time, but there's another function you can run, and if you want to deal with flux, but that's something I was showing earlier, because I'm already using Spring Cloud Function on the class path, so you can use a variety of different programming models. But the bottom line is that you just develop functions. You focus on the business logic, you focus on the functional code. And we'll provide the mechanism, again, managed through boot by auto configuration, by something that you bring into the class path and maybe additional configuration for edge cases where you simply say, okay, well, I want this function to be composed with another function and bound to this destination. That's a deployment decision. Your app is just function, consumer, or supplier. Thank you very much, and I'm glad you were able to join me today.